Well, good morning, everybody, and welcome to the UKSTT's Trenchless Tea Break. This morning we have an excellent and very experienced speaker and a substantial audience, 65 and rising at the moment, so without delay, let's begin. Before introducing our speaker, let me remind you that you can ask questions by posting your question in the Teams question box, which you should see on your screen. Our speaker today has committed a lifetime of work to the water industry and been a great contributor to trenchless technology. So I'm pleased to introduce Nick Orman. Nick attended the University of Nottingham 1975 to 1978, which was some time ago, obtaining his BSc in civil engineering. He joined Bury Council in 1978, worked there for 5 years, and moved on to Rochdale Borough Council, working there for 3 years until 1978. Sorry, beg your pardon, until 1983. He joined WRC in 85 and has spent almost 35 years there, currently as principal consultant Pipe Networks. In addition to that, he's worked as the group secretary for the SEN committee dealing with drains, sewers and outside buildings. And in that role has put in more than 27 years. So a great contribution to the industry. I'd say deserving almost a round of applause. So, Nick, would you like to click on to the second slide, please?
Okay.
Yeah, just a reminder to use the question box function to ask questions during the presentation, and we'll answer those at the end of the webinar. The webinar is being recorded and will be available to view after the presentation. The third slide, please. And this is to remind you, of course, that the UKSTT offers a myriad of technical resources and deals with inquiries on a regular basis. So please make use of your organisation and get the best value for money out of it. And the fourth one, please. Right, you're off. Well done, Nick. Good luck.
Thank you, Dick. I'm going to go through just a brief introduction to SRM for those who are not familiar with it, and then look at some changes to the design methods, and then finish up with a bit on quality control. So first of all, the background. I remember in 1983, my boss bringing me this red book and putting it on my drawing board, saying, I think you need to read this. That was a long time ago. It's now in its 6th edition, which is only available online at the moment. And there's been relatively few changes to the calculation methods since that 1st edition. This new 7th edition, which will be in a book, changes that. So first of all, changes to the design methods. We're moving to design using the partial factor method. So most structural design methods for sewer liners in Europe now use a limit state approach using partial factors. The sewer renovation design methods in France, the ASTE, and in Germany, the DWA method now uses this approach. Also, we're applying the principles of the Eurocode design approach. This isn't a Eurocode design, because for it to be a fully compliant Eurocode design, there would have to be an appropriate part of EN 1990 series to match it. But it's taking the principles out of EN 1990 and applying them to this design method. It offers a better understanding of the variability of the material properties, which given that some of the materials are cured in place, either as grouts or as a cured in place liner, is quite important. Someone's described it to me once as complex chemistry in the bottom of a trench. And it gives us better ways of managing quality. But I suppose, put simply, the EN 1990 approach is now considered best practice in structural design. So we probably ought to be using that. A little bit about design by partial factors. Basically, for characteristic values are those that are either the highest, the 5% of, so the value of which 5% of the results are above, or the lowest, what the fractile are 5% fractile, where 5% of the results are below. So the normal one will be the 5% fractile value. That's the safe one. But occasionally you might have a value where a high value gives you the worst case, and in that case the 95% fractile value is used. That's all standard stuff. So first of all, characteristic values for elastic modulus. There's a bit of a complexity here. Hitherto, we have used the mean value of the test values, and in normal case, that is what EN 1990 would recommend. However, in this paragraph, there is a note. In some cases, a lower or higher value can mean for the modulus of elasticity may be taken into account, e.g. in the case of instability. And that instability limit state is actually one of the most important ones we use, which is buckling. So in a buckling limit case, where due to external water pressure or grout pressure, the liner would implode, if you like, the limit state is an instability limit state. So for that, we're recommending that the lower characteristic value should be used for design. In other cases where it's just used for calculating other properties, then the mean value would continue to be used. So let's now look at type 1 design first. So just a refresher, type 1 design method is where the existing host pipe, the grout and the liner are used as a single composite structure. And this requires obviously a bond between each interface for that to happen. So the key changes are that we've updated the traffic loadings. We've assumed that cracked structures are fully grouted. So when you're grouting the annulus, you're going to be grouting the cracks in the host pipe, if there are any. So that the whole composite structure is a rigid structure. We've got a new method of calculating the design bending moment, and also more importantly, a more rigorous method of calculating the section properties of the composite structure. And finally, there is an additional limit state for strain at first break when to ensure that the strain compatibility of the liner and the host pipe and the grout. So first of all, updating the traffic surcharge loads. So the traffic surcharge load is now in line with EN 1991. These are higher than the original SRM values, but reflect changes in the standards since then. Design loads are given for both field loading and highway loading, and these are in line with the ones in BS 9295, the most recent 2020 edition. But if you want to consider other loads like railway loadings, then you can go to BS 9295 and use that to produce those loading cases. So the design bending moment, the new method uses the method developed by Moore and Doherty in Canada, which essentially licensed the composite structure to a new pipe. And they've done work on that and tested it in conditions, and that essentially produces something that is nice and simple to use for circular pipes. For egg shapes, it's a bit more complicated, and but fortunately, a BS 9295 produces us a very nice method for calculating the moments, bending moments for those. That's for a 3x2 egg. I realise that this doesn't cover some of the more exotic shapes, but that it does cover the vast majority of shapes that are in use in the UK. A little bit about strain compatibility. If a liner has a low elastic modulus and the grout has a high elastic modulus, then before the liner has had a chance to take up the design load, the grout would have had a strain that is beyond its crack value. So the grout would have cracked and you no longer have a composite structure. So we've introduced this additional check on the strain at the grout interface between the grout and the liner. And this is effectively derates liners with a low elastic modulus, so particularly GRP liners in type 1 will have a much lower design value because of this. Going on to type 2 design, I'm not going to introduce these as things we've changed, because the first one is things that we haven't changed. It was suggested that using the highest hydrostatic load was too conservative, as it doesn't happen very often. But we've looked at that, and I'll go into that in a minute. There's a new method of calculating buckling resistance, and this is also new method of buckling resistance is also applied where it takes place in type 1 and type 2 liners. So first of all, the hydrostatic load. The case was put that groundwater is a transient affair, and therefore we should be using short-term properties as a lower, and then doing a check on a lower pressure for the long-term properties. If you look at the graph on the screen, you will see that the movement between the short-term properties and the 50-year property is a log graph. It's a straight line on a log-log graph. And so if you look at the time axis, it's very skewed. So high groundwater can last for 6 months in a bad year. And I've drawn on this graph the point where the 6-month value would be. And as you see, it's very much nearer the 50-year value than the short-term value. Even if you went down to 1 month, it would be still roughly in the middle of the axis, a little to the right of the middle. So clearly using a short-term value for a high groundwater transient is not an appropriate approach. So we haven't changed that. The most significant change is the change of the equation used for buckling resistance. So hitherto, we've used the unconstrained buckling formula from Timoshenko with an enhancement factor to allow for the constraining. Since then, the Glock formula for fully constrained buckling has become the norm, and so we've adopted that as it gives a better fit. So if you look at the graph here, the dots represent some test values, and this is taken from a paper by John Gumbel and uses data from Ogwald. The steeper chain dotted line is the Glock formula. The single dotted line is the Timoshenko formula without the enhancement factor, and the dark solid line is the enhanced Timoshenko. And as you'll see, for very high values of SDR, the Glock formula is much better fit, and the Timoshenko enhanced is actually quite conservative. So you're over designing at that end. However, at this upper end here, where you've got SDR less than 30, they are much more aligned, and potentially as you go lower, they could be an unsafe design. So we have moved this much better formula. Obviously, where you start to have a gap, then you have a reduction factor, and that's built in. So the method is applied by calculating the critical buckling factor from the Glock formula, but applying a reduction factor R, and the full reduction factor is R times two elements, one for the gap and one for ovality. The gap factors are based on the work of Boot, and Boot also did some finite element analysis work, and using that calculator that he developed from that, we found that the Timoshenko ovality factors could be applied here as well. So that is what we've done. For non-circular liners, it's a bit more complicated. Boot identified that there was also a limit state for not only the buckling, but the tensile failure of the liner wall in this critical area here. And so actually with non-circular liners, we've got two limit states here: buckling resistance and tensile failure of the liner. The software to produce this is quite cumbersome. It would be nice to produce some software for it, but at the moment we've used the software to produce some design charts for 3/2 egg. Buckling again is a similar approach to the circular with two reduction factors, but the tensile failure is more complex, and you have to select a design curve based on the ratio of the elastic modulus to the tensile strength. So those are the changes to the design method. And now I'm going to talk a little bit about quality and managing quality. This is an area where in the past perhaps we've not given adequate consideration to, and is much more coming to the fore now. The the product standards for liners, the ISO standards, now require manufacturers to declare values for the design parameters. Unfortunately, they don't state how those values should be declared. I mentioned that renovation often involves this complex chemistry in less than ideal conditions. And there's also a need to understand the difference between the long and short-term properties, because the long-term properties are what we're designing to, but in a quality control situation, you can't do a 14-month quality control test. You have to use a short-term test. And we also need to understand, when we're looking at a small sample of test results, how that fits in with the variability of the materials. So going back to this graph, first of all, we are looking for either a mean or a 5% fractile value, a lower characteristic value, depending on the application we're using. The temptation for a manufacturer might be to declare a value that's that's lower than what he knows he can produce, just to be on the safe side, to ensure that the product always passes. But that is actually a recipe for trouble. The reason is go back to this long and short-term property graph here. The short-term value is an instantaneous value. It's a 10-minute test. The longest test we do is a 10,000-hour test, which is about 14 months. And that's extrapolated to a 50-year value. Essentially, what we're doing, if you talk in terms of EN 1990, is we're applying a fixed conversion factor. We're saying that the long-term value is related to the short-term by this factor, conversion factor, nu. But that factor is only applicable to a particular product. If your product hasn't properly cured, then there is no guarantee that that value is still the same as the one as if the property had cured. So you could have a product or a sample that hasn't properly cured, that is below what should be the short-term test value, but if the declared value has some added factor of safety in it, it could be that it's not telling you that it hasn't properly cured. And therefore, that conversion factor may not apply. So you need to ensure not only that it achieves the declared value, but that that declared value is actually what the product was designed for, that the thing is properly cured. So we need to ensure that that declared value is based on the manufacturer's tests and consistent with the manufacturer's tests of properly cured product. A partially cured, so I explained that about things. So, but then you've got the variability of material. So because we're talking about a mean, should we fail something that's less than the mean? Well, actually, no, because half of the products will come in less than mean. What we want to ensure that it's within that envelope of the defined by the standard deviation. And so even if it was below the 5% fractile value, it's still, that's 5% of the results are in there. So that's not a reliable test. So what we're saying is that we need to declare value tests for the mean, the standard deviation, and the number of samples tested. We can then apply statistical methods, standard statistical methods, to ensure that the mean and standard deviation of our test values are consistent with the mean and standard deviation of the manufacturer's data. Then we can be sure that we are within that envelope of data to ensure that it's properly cured. And that means there will be a small number of QC samples that are going to be below the 5% fractile, and half of them should be below the mean. But that we shouldn't trouble ourselves with that. That is what we're trying to achieve. And that is essentially all I had to say, which is a bit quicker than I'd intended, but there you are. So we've got time for questions now.
So thank you very much, Nick. That's a very, very interesting presentation. And I'm sure that we will get quite a number of questions. I have a couple that I'd like to ask you a little bit, if I may, before everybody piles in with their questions. The revision of the SRM design method has been discussed for quite a while. What's been the driver to finally get this long-awaited action implemented, and what measures will be taken over the next few months or years to get the new methods adopted by sewer owners, their designers and contractors? For example, are there training programs planned or technology transfer sessions, or is it simply a matter of a new document, a new SRM, and there it is, pick it up and work with it?
We are planning some training sessions. They haven't been publicised yet, but there will be some rollout sessions to help people through the transition. The driver, I suppose the final driver was this quality thing. The people in the past had been fairly uninterested in the quality, and that has changed in the last couple of years. There's a much greater interest by clients in ensuring that the quality of the work is up to standard, and so that has been the most recent driver to get this done. And where products are WRC approved, we will be working with those when they are come up for reapproval to ensure that the stated design values are properly justified, declared values are properly in line with what we've been saying.
Good, thank you very much.
That's two angle things, one from the designer and another from the manufacturer.
And you mentioned that the similarities with the French and the German systems. How closely does this new approach align us with those practices? Is it very close?
It's fairly close. The methods from the French and the Germans, reflect the culture of their particular countries. So France has a very elegant mathematical design, and we've they've produced some software which we've used, and the Germans, it's a very long calculation. The essence of the SRM approach, though, is to try and keep it very simple, to both help the designer produce something simple that will cover the vast majority of cases, without going into too complexity, but still understanding what's going on. I mentioned that we have concentrated on circular and the 3x2 egg shape, and I recognize that there are some designers, so there's very few that don't fit those, and perhaps these more complicated continental methods might be an approach that could be used in those circumstances. So if we can get the boot software to be more of a designer's tool rather than a researcher's tool, then that might be also an approach where we can move into different shapes.
Good, thank you. We have a question on the screen. I don't know if you can see it, but this is from David Pitt. What he's saying is he thanks you for an excellent presentation and says, while accepting the need for standardization, for coding and classification of defects, and therefore mechanisms for determining the rate of deterioration and the timing of remediation or replacement, could you advise what steps are now being taken to use new technologies such as LIDAR and 3D infrastructure modeling? He goes on to say, by producing baseline surveys, all subsequent surveys performed provide unquestionable opportunities for change recognition comparison, achieving far more reliable forms of assessing the rate of deterioration. So I think he's looking for your general comment on that approach.
Certainly, the SRM does address that in part one, the sewer rehabilitation planning approach, but and certainly we're considering that part, but we wanted to separate the two parts, because what has happened in the past is when we've updated the SRM, we've concentrated solely on that first part and done very little in this second part, and we wanted to separate the two so that that didn't happen again. So we're dealing with this, and then we'll move on to look at part one later. If I can dodge David's question in that way. But certainly we're aware that there is an issue, and that but the rate of deterioration is actually a very complicated assessment, because we're not talking about a pipe deteriorating, we're talking about a pipe and the soil and how they interact. And it would be apparent that, I mean, you can do quite a lot on inspecting the pipe, but unless you know how the soil's reacting around, you're not getting the full picture.
Right, thank you. There's a further question from David, which we'll reserve to a bit later. In the meantime, Tom Sangster asks, when will the 7th edition be available?
In the autumn. We're going through a peer review and proofreading process over the next few months, and so to produce a book actually just takes a while, so should be out in September. Right.
On LinkedIn, back in November 2020, you posted a very interesting article briefly on the material property issues, and this is a very big step forward, I think, from where we were 10 or 15 years ago. And I believe that the ISO TS 23818 group were going to produce a draft specification for testing of CIPP. Is that also coming soon?
That should, I haven't checked on that at latest point, but it's certainly been out for public comment. So given the way that ISO works, that shouldn't be long. So it'd probably be also in the autumn.
Right. Good, thank you. So we've got a further question from let me just scroll down. Phil Clipsham. Again, he thanks you for a very interesting presentation. He says, I've seen new lining products and systems proposed and wonder whether you are happy that national/international standards adequately ensure that lining systems are fit for purpose. In other words, are the 10,000 hour tests sufficient? He says he's seen liners fail during grouting. And has any of the advice changed for these temporary loadings?
Liners failing during grouting, we have changed a little in that we now assume that during grouting the liner is totally unconstrained. So previously, in some cases, it was considered partially constrained. So that actually the Timoshenko equation for a circular liner is much more appropriate then, but with no enhancement factor. So in a sense, that's a bit more cautious. In many ways, if a liner is going to fail, I'd much rather it failed during grouting rather than in service. But I recognise better still that it doesn't fail at all. And I think that's where this renewed emphasis on quality is important. As to is the 10,000 hour test adequate? That's a difficult one. Rather than saying I'd like it to go on for more than 10,000 hours, I think I'd rather we did more 10,000 hour testing. That's not going to be good news, what the manufacturers want to hear, but I think that's where we need to, the direction we need to go. I did hear when we move on to lining of pressure mains, rising mains, then I think because of the cyclic loading instance, then more testing will be required, particularly of materials that might be susceptible to, well, it's not quite fatigue, but fatigue-like failure. Has that answered Phil's question?
I think you have. I'd just like to add an observation. I think another aspect of that 10,000 hour testing is better definition of the preparation of samples and the testing of samples. But that's just my opinion. We have a question from John Gumble, which is, will the new SRM recommend specific partial factors on actions, brackets loads, and material resistance, and when will these be published?
Yes, it does. And I haven't included them here. The partial factors for actions have been aligned with BS 9295, just to keep things simple, and they seem to be a reasonable set of partial factors. So that's the easy one. And we've also tried to align the partial factors for other materials with those for similar materials in use. So, for example, the partial factor for grout is aligned with partial factors used for concrete in reinforced concrete design. For CIPP products, where there isn't a sort of established partial factor, we've actually aligned with the French and taken a fairly high partial factor. I'm just don't want to quote it off the top of my head in case I've remembered it incorrectly, but it's around 1.5, 1.6. Finally, for the grout interface between the laminar shear between the liner and the grout in type 1 loading, we're still thinking about that one, but that's going to, because of the workmanship issues in that, and ensuring that the grout is fully in contact with the liner all the way around, particularly at that crucial top end, we're looking at a fairly high partial factor, probably around 3.
Thanks. Moving on to the next question, which is from Jari Kaukonen, ISTT chairman and calling in from Finland this morning. Can you see a possibility of having equal calculation methods around Europe in the future? Clearly we're moving towards that, but what do you think about that?
We're moving in the right direction, and this represents a general alignment on the Glock buckling approach, and I think that's a good thing. I know CENTEC 165 Working Group 13 and Working Group 22, which I used to be secretary of, and indeed Working Group 12 on static calculation for new pipes, have been in discussions for a little while on possibly aligning. This is not likely to be a fast process, but I think we can align on a few things first and then gradually converge over time. I think the key thing is, though, that whatever comes out needs to reflect the culture of the countries where it is done. So I mentioned that in terms of the different methods. So I could see that we'll have at least doing calculations that do the same thing, that the UK might be something that's a little simpler to do, even if not quite so elegant as the French, or as quite so exact as the Germans.
Thank you. Yeah. I think you'll like this question. This is from Simon Bull. Does the WRC intend to introduce or encourage a league table for installations for their QMS like the IKT produce?
I'm not sure about a league table, but certainly some independent assessment of testing and assessment of the reliability of products and indeed installers, because in many cases it's not just the manufactured product that's the key, it's actually the installation, and where you have a manufacturer that sells widely to installers without really controlling the quality of the installation, then that can be as big an issue. But I think we really need to up our game on quality. We need to make it a much more scientific. I have reservations about the IKT line of trials league table is really great. It's really focused on quality, but because of this declared value thing, I just have a few reservations of whether it's quite there yet, and that we need to do something that reflects this statistical approach. more closely, rather than something that would incentivize. I can't say that the manufacturer has done this, but it would incentivize the manufacturer to declare a value that is sufficiently less than their test results suggest to ensure that they always pass.
Great, thank you. Mike Barber writes, hi Nick, for your discussion. In your discussion regarding changes in groundwater levels, does the updated design equally apply to sewers which are to be lined in coastal areas affected by tidal changes?
If it is purely tidal, that's still, you know, it depends how widely that, it depends on the timing. If you do go for a shorter term thing on a tidal one, that is up to the designer. But remember that the short term is actually a 10-minute test, and that even the hourly test is, you know, even a 1 hour test has gone a long way down that, because it's a long graph. So I think we need to be aware of this if you're going to do that. Yes, tidal is shorter, but it's not 10 minutes, unless it's at the very top of the tidal thing. And you've also got the variation of spring and neap. So yes, it's open to the designer to consider that, but consider it knowing all the facts and considering the properties of the material concerned over time.
Good, thanks. Bert Bosseler from IKT has made a supporting comment. I think he says the SRM now seems to be well in line with other European ideas on liner design, but he asked the question, how does the SRM approach now compare with the US systems, for example, the ASTM 1216 calculations?
Well, the ASTM is essentially still using Timoshenko, so it doesn't align, is the short answer. And I think I think that the ASTM needs to move to a Glock-based approach.
Yeah. However, there was a paper about 2015 where Ian Doherty commented that the ASTM delivers very similar results to DWA. So the gap is not huge, is it?
No, the gap is not huge. I think the concern I'd have is, as we innovate new products, we move outside the envelope of the material properties that we're comfortable with. You know, we've become, in a range of products, we've become comfortable that, yes, they don't give too different a result. But as we innovate, we move out of those regions. So we developed the SRM, the Timoshenko approaches at a time when we didn't have the reinforced CIPP liners with glass in. So these products are radically different to the products we had before, and I'm sure there's going to be further innovation. So we need a method that does fit us for the future.
Yeah, thanks. And a question now which is more broad in regard to dealing with issues that might come up in the new SRM. Richard Swan writes to say, in his experience, the designer makes a range of assumptions to save money which maybe cannot be achieved on site. How will the SRM address this?
By putting a bit more information in on why decisions have been taken, so that I think you could justifiably criticize the SRM for just keeping it very simple and not explaining the background. And we need to, without making it so complicated that nobody will read it, which is always a danger, we do need to quite simply explain the issues so that designers can use their heads rather than treating it as a black box.
Yeah. Right. Going back to the design method, Martin Long asked the question, is CIPP only designed for groundwater pressure as a type 2 liner, or does the method include a way of taking account of traffic and soil loading? And I think many of us who've used the SRM over the years have been a little confused in how we should deal with traffic. It says deal with it in defined circumstances, but isn't clear on how to deal with it. You have to go back to much earlier documents, which in themselves are a little difficult to read. But do you have a comment for that?
There was some work done at in collaboration with Jess Boot, but done on centrifuge trials at Cambridge. I'm trying to remember the researcher's name at the moment, it's just snapped out of my head.
Yeah.
And Kenna. And they looked at how pipes perform, the liners perform under this loading case. And essentially, the host pipe was taking the traffic load, or the host pipe soil interaction was taking the traffic load. Unless you've got a very shallow pipe, then it does appear that the type 2 assumption that the host pipe soil interaction can take the traffic load is entirely valid. Where I have a problem is if you've got a very shallow pipe. So if you've got a pipe that is shallow in proportion to its diameter. So if you've got a 150 pipe 2 meters deep, absolutely no problem. If you've got a 2 meter pipe with only 300 mil of cover, then you need to do something rather different. And I'm not sure you're really into a simple type 2. I think you probably need to do something much more complicated to that. The difficulty is that where this soil arching takes place, where the soil really takes the load, we don't properly understand. We make some assumptions, but that's an area where there really needs to be more research relating the soil properties and the potentially the compaction over time to the load on the pipe. I think that is certainly an area where we could, if you were to say that the pipe cover was 5 times the diameter, I'd be really comfortable, there's no problem. But actually that's not, once you get into bigger pipes, that's not always the case. It might be okay as 2, but I don't know. That's where we need a bit more research.
Thanks. Steve Peregrine asks about the SRM coming up in the autumn. He says, when the printed SRM 7 becomes available, will existing customers still be able to access it online?
So as we update from 6 to 7, then existing customers will have to pay for an upgrade, but for the part that we've updated. So if existing customers have got currently online access to both parts 1, the planning, and part 2, the rehab design, then if they don't pay for an upgrade, they don't get the upgraded part 2. They just have part 1. So that's how we'll cover that.
Okay. Sandra
And
Roth,
ultimately, when part 1 is updated, they'll have to pay for an upgrade for that.
thanks. Sandra Rolfe Dickinson asks, and thanks you for your presentation, particularly for mentioning rising mains, and asks, will they be covered in the new work?
We thought about it, but actually we think there's quite a lot of work needs to be done before that they can be considered mainstream. I'm particularly worried about the cyclic loading on the liner and the effect that might have on its long-term properties. And I think until we've got some good data on what both from tests and from field trials to know exactly how that works, I think it would be premature to write it into an established design document. I'm particularly worried about fittings. So with a gravity sewer, you don't have a pressure fitting. Obviously, with a rising main, you've got a coupler, and that has to couple to the liner, and it's what forces and movement will happen around that coupler that worries me particularly.
Okay, thank you. And the last question I've got on the list here comes from South Africa, from Alistair Goines. He asks, will the 7th edition be available in electronic format? I think
I've answered that.
Yeah, I think so. So really, that's all the questions that I have, and I didn't need to use any more of my reserves, so I think you've done a wonderful job. Thank you very much for working hard through all of those. If you could click on to the next slide, please. This refers to the next webinar, which is on utility mapping and detection, with Colin Tickle and Andy Gundry as moderators, Neil Bramall, Paul Nichols and John Robinson as speakers. That's Wednesday, the 2nd of June, 11 AM. So put that in your diary, folks, and it's not very far ahead. So UKSTT is coming at you thick and fast with good information, which is a great thing to see. I'd like just to close by thanking Nick for his exceptionally hard work this morning, making a really interesting presentation, telling us a lot about what is coming up in the autumn and what will be a real step forward for our industry. There will be a lot of challenges, I think, in adopting these changes, and a lot of questions, but it helps to understand that the material properties aspect is one of the key things that drives this forward, and it can only be for a step in the right direction. So thank you very much, Nick, and thank you all for attending.